Okay, guys, can you hear me?
Yeah, that.
All right. Okay, sorry about that. That's why I don't like online class. Okay, because in the middle of it, something happened. All right, so we continue just a little bit more. So if you look at this, the grade there. So what you see here is that. Hey, am I sharing the screen? No, why?
Ada.
Okay. Okay, you can see the screen, right? Okay, so if you look at the semester two, the previous one was 2022-23. Okay, and then 2023-24, you can see that numbers of A and A minus increase, okay, to 16, and number of fail is only 1. Okay, this is only my section, okay, I'm not including the one that the other lecturer teaching, okay. And then this is consider high lah. Okay, for A and minus is 16 because normally for another lecturer, example Dr. Faid is teaching another section, right? So normally A is very hard to get. A minus maybe 1 only. Okay, and then fail maybe a bit little, but you don't have A minus in that section. It's not saying that I'm lenient in marking. No, I'm strict in marking also. But I believe that maybe because of the method that I teach to students, and they get to understand how to apply it to the question. Okay, and then what happened in semester 24-25 last semester is that you can see that there's a drop, not a drop lah basically, but still about the same. If you see the number of AA minus is about 15, about the same. Okay, and then the fail rate become 3. This is why fail rate become 3. Okay, suddenly from 1 become 3 increasing. So I can see that when I do analysis, I as a lecturer we do analysis on CQI, how to actually improve why this fail rate happen to some student. Okay, so basically what happened to this student, why they fail is on because of midterm exam. Okay, midterm exam. Okay, basically if you see here the midterm exam for semester 24-25, actually very little student get more than half marks. Okay, this is half marks. Full mark is 20 marks. So 10% marks, only about 26 or 27%. About 73% more than half mark. So means that very bad lah. It's not because of the question is tough. It's because of the student. When I teach in class, I thought student understood the fundamental because when I teach, there's nobody asking question. Everybody is like, understood, doctor, understood. Okay, I was like, okay, I feel that a student will score. Fortunately, they didn't score lah. Okay, so I'm a bit sad. Okay, a bit like sad about what happened because they should be scoring because this question was easy. So what I will say for your batch is that make sure that before you go to midterm exam, every question that I ask you to do in Padlet, past year exam question, please make sure that you do the question. Do not ignore it. Okay, because I'm not going to cover every past year question because that will be your exercise on your own. Some I will cover, but some you need to do on your own. And we will later do a comparison. Maybe if we have time, then we will have a revision class before the midterm. Okay, but the thing is that please do the Padlet exercises if you want to pass. If you don't want to pass, then go ahead, don't do anything for this class. Don't jot down anything during class. Okay, you can just listen. And then for the exam, don't study, and I'm sure you're gonna be failing this subject easily. Okay, but I'm not going to do. I'm just saying that opposite of what you should do lah, because normally students do that opposite thing. Okay, so I hope that students take note on that. And this is a reason why student fail. Okay, last message QI. Okay, student lack of exercise for each chapter. You can see it's frustrating. The analysis that I do is that after looking at why student fail, didn't do the question, even though similar question for exercise but cannot answer. Chapter 1 fundamental. Because fundamental chapter was very weak, then chapter 1 and 2 convolution also student cannot answer. Okay, because it's related. Okay. Assignment, same thing. Same concept. Same thing. Student cannot do it. Because why? Even though it's an individual assignment, but some student, they just ask the other student, oh, can I copy the assignment without understanding it. So piggybacking on other student hard work will not help. That hard work working student will score, but you are not going to score. You are going to fail. Okay. Student didn't reverse back example exercise that I discussed in class or Padlet. Okay. So basically, if you don't do revision, then you're not going to pass. Okay, if you want to score, you need to do revision more. 3 times the effort. And this is very frustrating. Chapter 5. Chapter 5 is the last chapter, and unfortunately, that time during that semester, that week was Raya Haji. So during that week, all students didn't come. Most of students, like less than 50%, didn't come to the class. Okay, physical class. There's no like hybrid class yet, okay, because the Raya Haji was during study week, but students just disappear. So unfortunately, because most of students didn't attend the chapter 5 topic, that was chapter 5 was the most easiest question. Students just skip that, and that's the reason why students failed the final exam or didn't get good marks lah. So what I'm going to say here is that my advice to all students here, okay, before you're thinking of, oh, I don't want to attend this class because so boring, lots of calculation. If you keep on missing it due to lots of cuti raya, Raya Haji, Raya Deepavali, Raya whatever raya lah kan, okay, will not do you any good. Okay, it will be a very bad move for you guys because it will affect to your CGPA, right? Okay, and when you don't study, you missing class, then it will affect to your final exam. So this shows. So basically, when the good student who did exercises, I know that, oh, this student really understand in class, put effort to do the revision. But if student cannot answer the final exam, most probably I know that they didn't put effort, okay, they didn't study beforehand, and that will be why you fail. Okay, don't cry to me when you fail. You just need to take again the subject, okay, the next semester. Okay, so this will be again, I'm going to repeat this. I think I don't know how many times students have seen this slide. Okay, aim for the sky. You see lots of things. Success, what you see for students that get good CGPA above 3.5 or 3.0. So you see only success. Oh, this student is very genius student. But what you don't see is actually here, down here. The dedication, hard work, good habits, waking up early, disappointment. Sometimes they're disappointed. Okay, maybe but you don't know. Okay, sacrifice your sleep, basically. Failure, sometimes you fail, but you cannot fail all the time. You need to pick up yourself and go and study. Persistent, again and again. Okay, persistent. Okay, like for today, you know what, I only sleep for 2 hours. Why you ask why I sleep for only 2 hours? It's crazy because I had to submit something, a video. I'm shortlisted to join MTE competition at WTC, okay, in April. So I need to do a video. Okay, UTEM asked me to do the video on Friday. Submission is tomorrow. So it's crazy. I need to do the slide. I need to do a video. I need to convert into a video. So yesterday was the whole day. I did it, and then I haven't finished it yet. Still doing the video. Okay, I slept around 3:30 yesterday because at that time my head is already like going to meletup basically kan. Cannot tahan anymore, so I go to sleep, and then 5:30 wake up for sahur, and then from sahur I didn't sleep until now. Luckily I still can talk right now to you guys. Fortunately that I like teaching, so it give me some strength to teach you guys. Okay, so adapting to UC Live. So you see this one, every time you see, you think you straight line like this. No, there's not straight line. Even doing PhD, there's no straight line like this. It's like this, the reality down here. You have like tsunami, like what I face in Japan. You have tsunami. You have the radiation, the radiation of the nuclear power plant. Okay, so that will be something that you're going to expect. Adapting to all of this take time, but you're already second year, should be you already adapted. If you're still not adapted, there must be something wrong with your habits. Okay, you need to change your habit. If you every time weekend you go back to your hometown, then you might need to change that habit by not going back to hometown, but instead having that slot to study or go and do some networking with your friends. Go and play sports instead of going back home. Okay. Okay, so adapting to life, well, life is just cruel sometimes or nice to watch, sometimes being slow, but when it melts, it's not nice to walk on it anymore because of the ice, black ice. Okay, life is not that easy sometimes to all of us. Back in Japan, I had to ride a bicycle or even walking. I ride a bike 40 minutes to the university. I think if you ride 40 minutes to university, for you guys, you feel going to complain. 10 minutes walking from your hostel also, you guys complain. Hot and everything. Okay, so this is earthquake. What happened after the earthquake after match? Okay, the wall actually break, some wall break, and then they are actually repairing it. Okay, but you do have friends in the university, so be friends somebody that have the same frequency with you. Okay, I'm not talking about senior system, but I'm talking about your own frequency. Find someone that have the same frequency. Okay, so that you can talk to them. Okay, so find sports, what you love to do. Go and have sports. Sometimes don't only focus on academic, because life without sports is so boring. Okay, you might be stressful later on. Okay, so if you are stressed, go and walk to the stadium, to the balapan over there, to the Tasik, the lake over there. It's lovely in the afternoon. Or ping pong. Or if you play ping pong, you can just join me at the Dewan Sukan for ping pong in the afternoon. Okay, so this is sometimes what you expect engineering. If you're not tired, you are not doing it right. If you feel okay, then maybe you have too much sleep lah kot. Okay, other student, they're sleeping soundly, you are sleeping while thinking of the equation in your head. For my case is that when I was doing PhD, I was thinking of doing experiment. Okay, and when I wake up, I will do this experiment and do a testing. Okay, so this is what you need to do. Okay, so let's do this last one. Okay, I want to get to know you. Some student, maybe they already updated them in the last year, but still I want to see who are you. Okay, so go to the Padlet. Okay, this Padlet, you can go to uLearn. Okay, under the activity 1.3. Okay, or you can scan this QR code also can. Okay, I'm going to paste this in chat. So click there on the Padlet. Okay, in the chat. Okay, go to that Padlet. Okay, open the Padlet. You will see on week 1. No, week 1 ke? Wait. Where are the Padlet? Okay. Okay, Padlet. Okay, Padlet. This one. Okay, so you see that one let me know you. So I want you to do it now. Take 5 minutes, just very fast. Do it. So write your name. You can just click here. Go down here. Okay. Click on this plus sign. Click plus, and then you can just fill in. Okay. So the subject is put your name lah. Put your name or whatever you want to put gesture there. Okay, like myself, I put this one, Dr. Mariam. Hello guys and girls. And then in the text below here, okay, means that here, down here, you write your full name, your hometown, highest academic background. For example, if you're STPM, matrix, your intake, UTM intake or direct entry, state which semester or year you are currently. Okay, and then hobbies. This is additional. I want to see what's your hobbies. Yeah, don't tell me that your hobby is studying. Okay, so it need to be more other than studying. Okay, and also take a selfie and upload. So you can just upload here lah. Okay, you want to take a selfie, click on the camera. You want to upload, just upload this photo. Upload photo can be any photo that you have. So basically, yeah, I uploaded here. Okay, me and my cat. Okay, I'm background from Cheras, graduate PhD, Tokyo Institute of Technology, Japan. I'm been lecturing 21 years. Okay, at UTM. And my hobby is ping pong. Well, currently lah ping pong. Sometimes ping pong, and then sometimes I'm off a bit. And then I have two cats. This is Tiger, and I have another cat which is Bella. A girl lah. This is a boy lah. Boy is a bit manja Okay, and then I also do gardening. Alright, that's my hobby lah. Okay, so you do it now. Take 5 minutes, update. Okay. Okay, done? Alright. So, okay, while you do that, we are going to continue the chapter. Okay, we directly go into chapter 1 so that at least you know what you're going to learn, okay, this semester. Okay, we have only 30 minutes left. Okay, so while you do that, you can do that later on also. Okay, so chapter 1, we are going to directly go into signal system. Okay, chapter introduction to signal system. So the content that we will cover will be the introduction, continuous time. Okay, continuous time and discrete time signal. Okay, transformation of independent variable. So this one we will learn about signal transformation. Then we go to exponential and sinusoidal signal. Okay, so sinusoidal signal including cosine wave and sine wave. Then we will learn about the impulse unit and unit step function, and also not including the ramp function, not including here. And then lastly is that apart from the signals, we also will learn about continuous time and discrete time system. Okay, and lastly is the basic properties. Okay, so this one I'll just skip. This is just a statistic, so you can just go through that. Okay, so let's look at why you need to learn signal system. So basically, the introduction about signal system is that it's all using mathematical technique. Okay, you are going to use calculus, complex numbering, differential equation. Okay, and why signal system is that a signal or a system can only be described or analyzed using with for example, if you look here, is that describe analyze system which process signal. So basically, a system here, if you look at the system here, it can be any system. Let's say the system is a motor, a motor, a DC motor. So for you to actually move the motor shaft, okay, output signal is a shaft rotation. If you learn about introduction to mechatronics, remember that. So input signal will be a DC signal, a DC voltage signal. So DC voltage signal, and then the output will be a continuous signal. So for that alone means that to analyze the system, you need to know what are the signal being given into the system. What are the signal input and what are the output being measured. Okay, so the signals for this case carry variable that carry all the informations. Okay, for example, 5 volt, 10 volt, what else? You have noise or not. Okay, and even the output, for example, if you are using ultrasonic sensors, normally the distance there will include the noise. So not most of the time, maybe you need to have a filtering. If you remember in Introduction to Mechatronics, filtering. So therefore, you need to filter out. How do you filter out? You do a low pass filter. Okay, and then the system is what you see here in the middle here, process input signal to produce output signal. So how does the motor move? It depends on the input signal. If you don't have input, then you don't have output. Okay, so for the introduction to mechatronics, you see that there are two graphs here. The first graph is, we call it as a continuous time signal. Let's say that input signal for continuous time are given it by xt. Okay, input xt. Okay, so system, if you learn, have you learned control yet? Control 1? Have you learned control 1 yet? No. Okay.
Yes.
Yes. Okay, if you have learned control 1, basically system in control, you normally label as GS. Okay. And the output, we normally write it as YT. Okay. So what does it mean? T. X, T, Y, T. Okay. Let's say that I'm going to just delete this for a while. Okay. So X, T, Y, T, we call it as a continuous time signal. So continuous time signal, okay, X in bracket T, Y in bracket T is a time, continuous time signal. Okay, sorry, continuous, where's the rubber? This is a continuous time signal lah. CT is not Siti Nurhaliza, is continuous time signal. Okay, it's short form. Okay, so when you see a bracket, this bracket, a bracket and you have a T, a bracket and then you have T. This is called a continuous time signal. So, and for a discrete time signal and continuous time signal, how do you differentiate between discrete, continuous and discrete time? So this one I will be labeled as continuous time signal. Why? Because the signal here you can see that is actually continuous. It's like a river flowing. Okay, you see that's like a river flowing. There's no cut off, kan? There's no cut off between the data. So that is called as a continuous time signal. Another signal that we are going to learn about is a discrete time signal. So you can see that discrete time signal compared with the continuous time signal is almost the same wave, but it is being sampled. So normally we have the sampling time TS here. So TS can be in 1 second, it can be in 0.1 millisecond, it can be in 0.01 millisecond, depending on the board that you're using. For example, in Arduino, what are the smallest sampling time that you can use? No, most of the time I think is about 0.1 millisecond. Okay, for DSP board that have high speed, you can go up to 0.1 microsecond. Okay, so the more smaller the sampling time here, okay, means that the sampling between this signal will be a lot lah. Means that you have lots of data in between. Okay, the larger the sampling time, 1 second, means that you have 1, 2, 3, 4 lah, like that. So you have less data. So means that the signal after you do a sampling, some data will be lost. Okay, similar like if I do an analogy. Okay, a river you see with your own eyes is that a river is flowing. Okay, let's say that you have a camera, a digital camera. Okay, you take a photo. When you take a photo, you snap it accordingly. You snap one, right? Or you do a repeating snap. You click once and then you will actually do a multiple shot. But when it does a multiple shot, basically it do a sampling of maybe 0.1 second. So you do not actually have a continuous photo lah, unless you want to take a video, that will be a continuous time. Okay, so discrete time, how do you write discrete time? So discrete time, you're going to write it as x means the input, okay, in square bracket n. So that's the difference. Okay, so when we want to write the system become g n square bracket n, and the output become y square bracket n. So that's the difference. So this is what normally student confuse. Okay, fundamental is weak. Why? If I give a question in the midterm exam, y in bracket t, they think it's discrete time signal, and the way they answer discrete time is wrong. Okay, the method is almost similar, but the way when you plot it, you will get the wrong answer. Okay, so first step is that to know how to differentiate between continuous time and discrete time signal. So how do you differentiate it? By looking at the bracket here. Bracket, normal bracket t is continuous time, square bracket n. Okay, the continuous time is t, square and for the discrete time is square bracket n. Okay, so same thing. So it doesn't mean that you limit yourself to x and y and g. No, we can do mt because I love m because my name is Mariam. Okay, sometimes we can use for example ct because you like Siti Nurhaliza, and then maybe other alphabet lah. Okay, but no matter what, this one will be considered as what signal? Continuous time or discrete time? Please answer in the chat. What signal? Continuous time or discrete time? Write down in the chat. CT or DT? That's all. MT and CT over there. Continuous time, correct. Okay, so that will be the first understanding of what's the difference between continuous time and discrete time. Okay, next, we go to system. Okay, similarly, same goes to what I explained just now. System can be in continuous time, system can be in discrete time. Okay, so if it's continuous time, then we can write it as xt. System will be GT. Okay, S is Laplace. Okay, GT and output will be YT. Okay, so this one will be discrete time. If it's in continuous discrete time, so discrete time will be X and G and Y and. Okay, so I hope that you understand that already. Okay, so what are example of system? So example of system is what you can see here, I list down here. So it can be a circuit whereby you can actually, what you have learned in circuit analysis is in time domain. Okay, time domain. Okay, sometimes maybe you have learned it in Laplace also in frequency domain when you convert from time domain to S domain. Okay, so you are going to learn circuit also in chapter 4 and 5. Okay, circuit analysis maybe you are going to use in frequency domain lah most of the time. We are not going to teach you in time domain because you have learned that in circuit 1 and 2. Okay. Example of system can be automobile. For example, you want to control a car, the speed of a car. So speed of a car, how do you control the car? By accelerating it. How do you accelerating the car? By pressing the pedal. Okay, pedal of the fuel pedal lah. Okay, and when you press that, then the car motor or wheel will actually rotate. Rotation will increase, therefore you will have increasing speed. Okay, so next example of system is also a camera, whereby camera is to capture the image. Okay, so like I said, camera, you actually do a sampling from the image of discrete continuous time to discrete time. So basically you are doing sampling. That's why you get a image at a certain moment only. Okay, and robot arm also is a system. Okay, so so what are the objective? Why you're actually learning in a system? Okay, so the first one is that you want to characterize a system in detail. So basically, you might not know what is the system, what is the transfer function of the system. So you want to characterize the system to understand how it responds to various output. Imagine that this system, okay, this system is a black box. Have you heard about black box? Not black box, the airplane, Black box is something that you don't know what is inside. For example, the box is closed, right? So you don't know what is it. Okay, but you can actually give an input to it. For example, I have a pneumatic system. Okay, I do not know how it will react to an input. So I'm going to give a pressure to the system and look at how does it respond to the input. And from there, I can actually plot a graph. Okay, a graph. Input versus output. So input will be pressure versus, for example, output, the pneumatic linear actuator example. So maybe linear lah in displacement, displacement. Okay, so for pneumatic, most of the time you will get a graph like this. Okay, it's a non-linear system. Okay, pneumatic. But if you do have a system that is a motor, a common DC motor, you will see that your motor will have a linear graph lah. Means that input versus output, means that input is voltage, you apply to a motor, it will rotate, displacement will be in a linear graph. Okay, so this is how you want to characterize the system, first one. Number two is that analyzing existing system. Okay, so estimating output parameter, you already have a system, but you want to confirm whether or not the system react to that. So you are going to do an estimation based on giving multiple inputs. Okay, by increasing the voltage, by giving different sampling time and so on. Okay, third one is that designing system to process signal in a particular way. Example, you know that when you, for example, a system here, pneumatic system, example, I attach a ultrasonic sensor at the displacement to actually detect displacement. Okay, might be the ultrasonic sensor have noises. So you want to see that how do you actually enhance or restore the signal that is degraded due to noise. So this is where you are going to design the system to process that current signal that you get. Okay, so example of what system is aircraft respond to both wind and command, electrocardiogram, the reading that you have from your heart, okay, may have so many noises, so you the doctors need to know how to filter it, but they are not doing it. That is under bioengineering. Okay, and then pilot combination with air control. For example, how do you communicate? What frequency do you use? Fixed frequency, so that they can keep on contact. Okay, this one is an example of an electrostatic sensor. Okay, this one I already explained previously in introduction to mechatronics. Okay, so electrostatic actuator actually runs based on input signal, whereby input is voltage. Okay, high voltage. So high voltage is up to 2 kilovolt or to 6 kilovolt, depending on the electrode that you use. So how do you actually move it? So when you actually apply the voltage to a different electrode, it is going to be from non-overlapping, and then because of the non-overlapping area, it will try to actually move so that it overlaps. So the force will actually move the electrode that is moving to the one that is static. So let's see example here. You have two layers of electrostatic actuator. This is base, fixed. The one that you see is fixed, the base is this layer, 1, 2, 3. So this layer is static. Okay, we call it stator A and B, whereby stator A is connected to V1, stator B to V2. Okay, mover here, you see here, mover here, is the one that is moving and is grounded, basically. So how do you actually move this actuator? Let's see that, if you see here, the black line is actually the hole between the electrodes. Okay, so basically it's not aligned right now. So because of the non-alignment, that's how you can actually control the electrostatic movement. Okay, let's say that initially both are 0 volt. We are going to give voltage V1, which is this stator first, and third one is with voltage, and you can see that because of we give the voltage to both sides, okay, and the grounded, so what happens is that you will have an electrostatic force attracted in between these two electrodes. So when it attracted, then means that it's going to move in the linear motion. The mover is the one that is moving, not the stator. Stator is fixed, so mover, it will be moving to the left side. Okay, thrust force will be moving to the left side, and when it is lined, then it will stop moving. Then how do you actually move it back to the right position? So we are going to do reciprocating motion, means that moving back and forth. So we are going to apply stator B to B, which is now stator B with the mover is not aligned. When you apply voltage to this stator B, okay, and you see that it's not aligned, so therefore thrust force will be actually applied here, and the mover will move to the right side. So this is how you control the electrostatic actuator. This is part of my PhD last time. I designed electrostatic actuator and designed the controller also. Okay, so part of it is how to understand signal. Okay, another example of signals and system is tsunami. Okay, tsunami or waveform that you see at the ocean. So you see there's boat here. Okay, there's a multiple wave here. You can see that there are waves that 800 feet, 500 feet, and 150 feet, and different frequency also. Okay, so this is example of tsunami, and the combination of multiple waveform at the same instant will actually become a tsunami. Again, this is we call as convolution. Okay, this is in chapter 2, whereby you will learn about how to actually do convolution integral for continuous time signal and convolution sum for discrete time. Okay, so let's say that this signal, I'm going to write it in terms of this waveform. So we have waveform 1. Okay, this is waveform 1. Oh, where's the, sorry, I will go out. Okay, waveform, this is waveform number 1. This is the frequency. Okay, waveform 2, 3, 4, 5, 6. So this is all the frequency for the all the waveform. So basically, all of this waveform later on in the Fourier series, you will learn about the harmonics. Okay, the first harmonic, the DC, this DC value. Okay, the fundamental value, the first harmonic, second harmonic, and so on. Okay, so basically all signals can be determined as harmonics of frequencies. Okay, and combination of this harmonic, example in at the ocean, when you have an earthquake, you have multiple waveform with different amplitude and frequency. And what happens that when they combine, they will become a tsunami, a large waveform. Okay, so this is example, a good example of signaling system for convolution. Okay, let's see an example of a real life tsunami, whereby back in 2011, I remember the date, it's 11 March 2011, because I was in Japan that time when the earthquake hit Tohoku. Okay, and there were the nuclear power plant radiation and so on, so I was in Japan. Okay, so it has still embedded in me the date and time. Okay, so let's look at the, can you hear the video sound? Can you hear it?
No.
Oh no, okay, wait.
No, doctor.
No, okay, wait, I share again because I need to share with sound. Share, include sound. Yeah, wait, share, sound. Okay? Right. Okay, can you hear it? Wait, why can't I hear it? Can you hear anything? Sorry. Mm. Can you hear anything? Okay, can you hear it? Okay, I start again. This is a real tsunami. It's from the helicopter view. So you see the line there is actually the first wave of the tsunami coming to the shore. First wave coming to the shore. Okay. So this is after all of the wave did the convolution in the ocean after the earthquake. So is he saying that Oki? Oki means like very large wave. So this is second wave. Is counting the wave EGD sign. Okay, 1, 2, 3, and multiple wave coming in into the shawl. So this is what happened in Japan last time. Okay, it was very scary because I saw it live. I saw it live. I was at the Yokohama, but we still can actually get a good connection to the TV that time live. So we were like, oh my God, are we going to be hit by tsunami also? Okay, so this is what happened in Japan back in 11 March 2011 due to the earthquake, Tohoku earthquake, Scala Richter 9.3 if I'm not mistaken. Okay, so most of the building in Japan are made from wood and most of them because they need to be earthquake proof. Okay, but not tsunami proof unfortunately. Okay, so this is the paddy field, right? So it's very devastating, devastating, looking at what happened that time. Okay, so let me just stop sharing again, connect this. Because, uh, uh, can you hear me? Can you hear me? Can you hear me? Hello, testing, can you hear me? Guys, can you hear me? Guys? Lama, kenapa tak dengar ni? Um, Hello, can you hear me? Testing. Boleh dengar saya tak? Saya macam tak dengar lah. I tak dengar you guys. Can somebody say something? Okay? You saying something? Okay, but I cannot hear you. Okay, but anyway, no, okay, no problem. If you cannot, I cannot hear you. But as long as you can hear me, Okay, so I share again. Okay, so this is the what we are going to learn later on. Okay, time domain. Okay, time domain. So in the system we have two types. Okay, the continuous time signal and discrete time signal. So this is GT and GN. So time domain we are going to cover it in the linear time invariant system in chapter 1 and 2, convolution sum and convolution integral. And for coincident domain we are going to cover in Fourier series, Fourier transform and Z transform. So chapter 1 and 2 will be time domain, chapter 3, 4, 5 will be frequency domain. Okay, this is why you learn signal system is basically because it's a fundamental of control. Okay, so if you look at this mapping, okay, of control theory, you can see that actually here is the, okay, here, where is my, okay, here is the time domain and here is the frequency domain. And you can see that you have the transfer function over here. You can see that you have the step input, impulse, sine wave. So later on you are going to learn this signal, and then you have the continuous and discrete time signal. So this is part of signal system, is a part of control. So that's why even though mechatronics student are going to learn about this because you are learning control. Okay. So this is similar to what I explained just now, continuous time and discrete time. Discrete time is almost the same waveform, just that you have a sampling of different sampling time. Okay, and you might want to try in MATLAB, try to key in this coding, and you can find out that you're going to plot a continuous time signal, and then Y is a continuous time signal, then N is a discrete time. So when you want to subplot to Y sine N over N, so you're going to plot the continuous time signal. When you plot N Y, then you're going to plot in terms of discrete time. So you can try that out later on. Okay, plot N Y will be a continuous time. Stem means that the coding for discrete time, you're going to plot for NY. Subplot 2 and 1 will be how you're going to plot the graph in terms of 2 by 1 or 1 by 1 or 1 by 2. Okay, so this one you try it on your own. Okay, so I think we don't have time. Okay, so I'm going to just go through this very fastly. Okay, so later on, since we don't have class, this Friday no class, next week no class, confirm no class, next week no class. So Monday lah, week 3, we are going to start with this one, physically. So we are going to do the time transformation of independent variable. So there will be two types of transformation, time transformation and amplitude transformation. For both time transformation and amplitude transformation, you are going to learn 3 different category also. Okay, so time transformation, you have the time shift, time reversal, and time scaling. So all is the keyword here is time, but you have the shift, reversal, and scaling. Another transformation is that the amplitude transformation. Similar to the time transformation, you have the amplitude, but amplitude shifting, amplitude reversal, and amplitude scaling. Okay. Then later on, you're going to learn about the periodic signal. Periodic signal means that the sine wave signal, okay, sine wave signal or cosine wave signal, okay. And then later on is even and odd signal. Okay, so you can try to go through the other notes, or if you feel that you are interested in what you are going to learn in the time transformation, you can just go to my YouTube, chapter 1 YouTube. So go and try to understand it. It's okay if you don't understand it yet, because week 3 we're going to go through it together also. Okay, so any question? Oh, low battery. Any question? Okay, don't forget this one. Please update it because I want to see your faces. Okay, and don't forget in Ulearn. Oh, where's Ulearn? Ulearn. Oh, Ulearn is already closed just now. Ulearn. In Ulearn. Okay, you will need to upload whatever that you jot today in class. Handwritten, I don't want typing. Handwritten. You can handwrite it on a piece of paper, then just take a screenshot of that and upload it as a proof that you attended the class. So whatever I talked just now, you must upload what I was talking about on chapter 1 or on the introduction slide just now. So how to upload? Go to week 1. Okay. Go down here. Okay. Don't forget to answer the survey form. Survey form, please answer. How many students? Answer already ni. Only 51 students. So we have 60 students. 20 more students didn't answer the survey. And then go to select the grouping. Okay, grouping, you can select your own group. Okay, own group. 2 to 3 students. Okay, ada lots of group empty, still empty. And then lastly is that Padlet just now. And for reflection, after each class, you're going to submit proof of attendance lah. So the one that you handwrite just now, scan it, upload, just click here. You should be able to upload it because it's open right now. So upload. Where's the upload? Why it's not open? Can you upload it? Oh, okay, make a submission here. Can you click on it? Why can't I click? Should be you can make a submission. Let me just switch the role. Okay, okay, yeah, here. This is a student role. So you can just add submission and just drop whatever JPEG ke PDF, whatever that you write just now, and upload it. Then that will be confirming your attendance. Okay, then apart from that, don't forget attendance here also. Attendance, where was it? Attendance, this is manual tick attendance. Don't forget to do it. It's still open until 11, 5 more minutes before it close. It will close on time. So do that now. Okay, any question? Any question? From student? Any question? No? Okay, who? Kek Kiang? Yes?
Good morning, Doctor.
Yes?
Yes, Doctor. I'm the diploma student from UTEM feeder program lah. So we just enter the class right now.
Oh.
So I just want to clarify something because for us feeder student, our Outlook email has minor issues. So some of us cannot log in into our account. So we may not join this class on time. Only some of minority of us join the class.
Oh, you cannot join the Teams link.
No, yes, because there are some issue on our account.
But you're from UTEM, right? UTEM
Yes,
feeder,
yes.
right? You cannot use your diploma email.
Cannot. I can just enroll the class using my degrees email.
Oh, okay. But I think the link is not limited to UTEM student. You can click on that and you can enter it anonymously.
Okay. Because we don't have any announcement for our classes, so I just keep searching on YouLearn and asking
for
the senior.
Okay, for the Telegram, did you join Telegram group?
Yes.
Okay, already joined. So you can wait. I think in Telegram group already. You can actually add your friend. You can add your friend. I think. Let me check the setting. Permission. Yeah, you can add your friend to the group if they cannot access from YouLearn, because I only give the Telegram access from YouLearn only because last time there was like scammer coming into the group. Okay.
Oh, okay.
So I only give it through the Telegram link through YouLearn only. Means that those who can only access YouLearn is only student. Okay. So for you guys, make sure that your registration for subject is under section 1. Is it
under section 1?
Under section 1, right? My class. My class.
We for our timetable we have just for this section only. We don't have other selection.
Oh, okay. So it's okay. So means that you're joining the section 1 class lah. So section 1 class, the class will be on Monday and Friday. But we don't have
Okay.
class this Friday because Raya, and then next week we don't have class also. So we are going to meet again on week 3 on Monday, physical class at UTEM.
Okay, understand.
Okay, alright. Apart from
Okay,
that,
thank you, doctor.
we don't have any exercises lah. Okay, so I think who else? Any question? No?
Okay, thank you, doctor.
Okay, thank you. Thank you, welcome. Any more question? I open my camera. Let's see if my camera can work. Oh, it's not working. Oh, because I didn't open it. Okay. Okay, so guys, so I think this will be the last class before the Raya holiday. So anything, I wish you all the best. Drive balik kampung safely. For those who are going back far away, maybe in the Pantai Timur over there, so drive safely. I'll be still working. Tomorrow I have class for Introduction to Mechatronics. I'm teaching FTCAP, okay, Introduction to Mechatronics. So 2 subjects. I mean, crazy lah this semester, 2 subjects. But anyway, see you guys. Have a happy Raya. Okay, have a happy Raya with your family and drive safely. Hopefully, we will meet again in week 3 on Monday, 9 a.m. Punctual 9 a.m. And we are going to be, I hope you are going to be excited to learn the signal transformation. Okay, so that be all. Please print your notes before coming to class. Okay, anything else? 1, 2.
Doktor.
Okay, yes.
Saya nak bagi tahu yang some of us, kita orang mobility student pass. So nama kita orang tak ada dalam list sebab result kita orang belum finalize lagi.
Okay, but you are going to join section 1, is it? Okay, sure, no problem. Later, just make sure that by week 3, your name is in the list for section 1. That's all. But you need to confirm with your PA lah. It means that your schedule does not clash with my class lah. My class will be on Monday and on Friday, Okay?
Okay, doktor.
Okay. How many student mobility? One only. Siapa tadi Fahira. How many student mobility?
Kalau untuk saya ada 3 orang. Tak pasti untuk ni mobility yang lain.
Mechatronics? 3 orang?
Ada saya, Firdaus, Afgan.
Oh, okay. Alright, so maybe the class will be more than 60 capacity lah, but we get the large BK, so no problem. Large BK is BK 3 and 5, so should be no problem for the capacity. Okay, so anyone else before we end the class?
Doctor.
Yes.
I want to say my account is just just from the diploma and direct entry to the degree, and my account have some problems. Now my name it shows other student names, so my name actually is Ong Hang Hui. So later the attendance, I will give I will write down my name. So maybe there is a Muhammad Faris that write other's name called Ong Hang Hui.
So you're Chinese. You are Chinese?
Yeah, I'm Chinese.
Oh, wah, kenapa tiba-tiba jadi Muslim? You puasa kot?
Tak. The account have problems. I already let the BPA know and with them to change the account.
Okay, alright. Okay, no problem. Anyway, as long as you submit in ULearn, when you submit, please make sure that you submit it. Everybody can access ULearn, right? If you cannot access ULearn, then just send to me what you have written today to my email. Okay, my email already posted in the Telegram group, okay, as a proof of attendance lah. Okay, so no problem. Either if you cannot access ULearn, then just send me an email officially. Don't send me in Telegram, because I cannot keep track in Telegram, for student submission, Okay, so anything else? No? No, Okay, that will be all. Thank you very much, guys. So see you guys. Don't forget to update the Padlet and do all the survey that I asked you in the ULearn. So with that, Assalamualaikum warahmatullahi wabarakatuh. Selamat Hari Raya. Early Hari Raya wish lah. Okay. Selamat Hari Raya, guys. Bye. Take care, drive
Thank you, Doktor.
safely.
Thank you,
Terima
Doktor.
kasih, Doktor.
Thank you, Doktor.
Thank you,
Selamat
Doktor.
Raya, Doktor.
Selamat Raya, Doktor.
Thank you, Doktor.
Okay,
Selamat Raya,
bye.
Doktor.
Terima kasih, Doktor.
Ramai rupanya.